Bonjour, ça va? That's it though, unfortunately. Despite several years of learning French at school, I don't think my linguistic skills are quite up to presenting a technical presentation in French. Right, we are going to talk about Java today and how Java is evolving, because there are obviously quite a lot of changes that are taking place with Java, both from a technical perspective, but also from the point of view of how Java itself is developed, how it is delivered, and how it is updated. What I like to do with these presentations is to start with a little survey of the audience. So who here is using JDK 8? Right, good, as I expected. Okay, anybody here using JDK 7? Okay, a couple of people, fine. Anybody using JDK 6? Ooh, a few people. Anybody using anything older than JDK 6? Oh, one person, no, two people. Okay, interesting. May want to try and move forward on that. How about JDK 9 in production? Okay, expected that. And JDK 10 in production? Nope. And JDK 11. Right, so a few people. Now that's interesting. So that's less than I normally see in the audience. I'm seeing more of a shift now towards JDK 11, but everybody is really still using JDK 8. Okay, so lots of stuff to talk about then. Right, JDK 9 is very significant, and I borrowed this slide from Oracle. I used to work for Oracle. I figure I can still use one or two of their slides. And it shows all of the features that were included in that release. There's about 86, I think, if you count them all up. But the important thing about this is Oracle being quite clear that this is, or was, the last major release of Java. And by major release, we mean one has taken several years of development to get to. So that in itself is a significant change. And we've already seen this, as we know, the fact that we are now talking about JDK 12 only 18 months after JDK 9 was released. So in the space of 18 months, we've had 4 releases of Java, 5 releases of Java, in fact. Okay, so what does JDK 9 give you? Now, I don't want to spend very long talking about this because obviously JDK 9's been around for a while. There have been lots of presentations in the past on the module system, but because many of you are still on 8, and presumably you're going to move to 11 or maybe a later release, then it's worth just mentioning a couple of things about modularity, because you will have to face this when you migrate applications from 8 to a later release. Really, modularity is about 2 things. One that you can effectively ignore, and one that you can effectively not ignore. The first thing is the fact that we have divided the monolithic rt.jar file with about 4,500 public classes into a number of modules. This is a very logical thing to do. It was somewhat overdue. And really, if you think about Java, we've already had the way of grouping together logically connected classes in packages. This is just an extension of that, where we're saying, okay, let's group together logically connected packages into a module. And then by dividing the JDK itself into these modules, of which you can see there's some 75 in OpenJDK, and there's another 14 in the Oracle OpenJDK, or Oracle JDK. It enables you to then build a runtime that only needs the modules that are required for your application. So that's the thing that you can effectively ignore. It just gives you the functionality that you need to build a runtime. The bit that you can't really ignore is the idea that Oracle had of encapsulating internal APIs. There are lots of internal APIs within the class libraries, and these are ones you're not supposed to. Ooh. Yes, brilliant. A new version of Java is available. So it is. I won't install that right now. Brilliant. Thank you, Oracle, for interrupting my presentation. Okay, yes. So internal APIs encapsulation. What Oracle wanted to do was to take all these internal APIs that you were never supposed to use and simply make them invisible to application code. Problem was that because so many frameworks, so many libraries use these internal APIs, things like Sun, Misc, Unsafe, it was going to break too much code. So they've kind of gone back on that idea, and now we have these various command line flags that can enable access through imports or through reflection to these internal APIs. So you may have to do some work in terms of setting things up on the command line to make applications work when you move to 9 or later. Now, as I said, by dividing the libraries up into modules, what we can now do is build a runtime that is tailored to our application. And the way you do that is using jlink. This is a very useful thing, because if you're doing something like microservices and you want to deploy a Java service into a container, what you can do is build a runtime specific to that service. It doesn't have to have all 4,500 classes. You only include the modules that you need for the application. What I've done here is just created a simple application, which I've called commas all zap. It requires some modules, both ones that I've developed and also ones in the JDK. If I run jlink, I can say, here's where the modules are located, the name of the module that I want to start from, and where I want the runtime to be built, which is my image. What that will do is build a JDK directory structure that looks exactly like the JDK, almost, which then only includes the modules you need. If you go into that directory and you say run Java with list modules, you'll see java.base, logging, SQL, XML, and the modules for my application, Zap, Zoop, and Zeta. This enables you to make a much smaller runtime than you would have if you take the full JDK. And you can do other things like you can strip out the symbol table, you can remove the manual pages, there's various other options to shrink it as much as possible to create a nice small runtime for your application. Okay, so that was JDK 9. One of the things that Oracle then did was they made a whole set of announcements at the same time that they released JDK 9. And they kind of put this under their marketing phrase of moving Java forward faster. What does that all mean? Well, first thing is this idea of a new release model for Java, which we've already seen. So now, rather than having to wait years, anything from 2.5 to 4.5 years for a new release of Java, we only have to wait 6 months. There are 2 releases of Java every year, one in March, one in September. And the idea is that that happens regularly. There is no delay. There is no pushing back on a particular date. It happens the end of March, end of September, every year. And we've seen this work very nicely because JDK 10, JDK 11, now JDK 12 have all been released on that schedule. JDK 13 has already started work. There are builds of that available already, and we will certainly see that released in September. The reason for this was to make the development of the JDK itself more agile. So it was this whole idea that, we use agile methodologies nowadays so that we can be more reactive in terms of changing requirements. Why not apply that to the Java platform itself so that we can add new features in a more gradual way, and where these are small features, we don't have to wait years for a simple change to the syntax of the language. We can get that very quickly. Bigger features obviously can be developed in the time that they require, but we still get access to small features as we need them. The way that this has changed the development of Java is now it's not driven by features in a particular release. In the past, when JDK 8, for example, started development, they would plan a set of features for that release. So lambdas and streams. For JDK 9, it was things like modularity. Only when all those features were ready would they release that version of Java. That was great, but certainly in the past, it's led to delays in a release of a particular version. JDK 9, good example. So now, rather than doing it by having features for a specific release, we simply release on a particular date with whatever is ready at that point. If a feature isn't ready, then it can be delayed because it's only going to be another 6 months before the next release. So we don't have to say, ooh, yeah, we should really sort of make sure that feature is ready and gets into that release, because it could be another couple of years before the next one. No, it's only 6 months, so we can release things more quickly and avoid putting features in if they're not ready. Now, because the release schedule was going to be much faster, Oracle said that it wasn't reasonable to provide extended support for every release. Obviously, we've seen 5 releases in the last 18 months, and if you wanted to provide extended support for all of those, the number of updates that they were going to have to create was just going to become unmanageable very, very quickly. What Oracle decided to do was to say, okay, we'll follow the same sort of model that people like Ubuntu do, and we'll determine that certain releases are going to be called long-term support releases, and only those will have extended support. What they decided was that one long-term support release would be created every 3 years. So 1 out of 6 releases is a long-term support release. JDK 8 was classified as a long-term support release because that's the one that everybody was using at that time. Well, almost everybody was using at that time. So they decided that that was what was going to be the first long-term support release. Now, I'll just put here, no more free JDK updates from Oracle, unless you're a desktop user, as you just saw with the little pop-up box that I got saying that there was an update for Java. For commercial users, the last update for Oracle JDK that was free was the one in January. The one that came out literally this week is not free for use in production. Even though you can get the update on your desktop, if you're a desktop user who's playing Minecraft, or if you're using some sort of older banking application, then you can still get the free updates. But the license for those has changed so that you can't put those into production in a commercial environment. The updates for non-commercial users will continue until, they say, at least the end of 2020. JDK 11 is a long-term support for the Oracle JDK. This is quite important. JDK 9, JDK 10, JDK 12 are feature releases. And feature releases do not have extended support, which means that there are 2 scheduled updates for those releases. In the case of 11, it was 11.01, 11.02, and then there will be no more public updates to that release, 10.0.1, 10.0.2. There'll be no more public updates to that. In fact, there will be no more updates at all to 9 and 10. There simply were no more updates. The other thing that Oracle decided to do was to create 2 distributions of the JDK. So the first was the one that we're all used to in the past, the Oracle JDK. That's the one that you go to java.oracle.com for, and you decide which particular version you want, which particular platform you want, and then you have to tick on this little box that says, I agree to the Oracle binary code license for Java SE. Now, I'm probably like you, and I've never actually read that license, so I don't quite know what I'm signing up to, but I know that there are certain field of use restrictions in terms of if you wanted to use an embedded system and so on. The thing that Oracle then did was they said, okay, we're going to create another distribution which is going to be purely based on what's in the OpenJDK source code. And so they called this the Oracle OpenJDK JDK. And you have to say it that way, according to Mark Reinhold, because he says that OpenJDK is an adjective, not a noun. So it's the Oracle OpenJDK JDK. The way this is distributed is under a different license. It uses the same license that you get for the OpenJDK source code itself. So it's a GPL v2 with class path exception. That protects you from the viral nature of the GPL license, meaning that your code, even though you're running on top of JDK, if you ship that with your application as a single bundle, you don't then have to provide the source code for your application because you're shipping GPL code in the JDK itself. For all of these, there is no concept of long-term support. There's only the idea of updates until the next release of Java. So 2 scheduled updates, 6 months. What Oracle then did was they decided that rather than having differences between the Oracle JDK and the Oracle OpenJDK JDK, they would converge these so that there would be no functional differences. Because if you look at JDK 10 and earlier, from a functionality point of view, you've got this core set of functionality, which is Java SE. That's what's defined through the JCP, through the relevant JSR. It's the language syntax, it's the VM specification, and it's the standard class libraries. OpenJDK is actually the reference implementation for that standard, but it's actually a superset of Java SE. There are a few things in the OpenJDK source code which are not part of the standard. The most obvious of those is the Nashorn scripting engine. So it is in the source code, but it's not part of the standard. And then the Oracle JDK was a superset of that, which had a number of additional features which Oracle included to make the JDK better. With JDK 11 and later, they are eliminating the difference between what's in the OpenJDK and what's in the Oracle JDK. So these differences go away. Now we simply have Java SE as the core, and then everything else is included in the OpenJDK. To do that, they had to do two things. The first was that they contributed a number of previously closed source features to the OpenJDK. Most notable of these was flight recorder, mission control, the tools that we can use to gather information about a running system. We can then graph it and see what's actually happening in terms of garbage collection, in terms of threads, in terms of locks, and so on. There are a few others, things like class data sharing and some other bits and pieces as well. The other half of this was that Oracle decided to remove a number of features from the Oracle JDK as of JDK 11. The most notable of these is the browser plugin. So applets effectively now have gone away. Anybody using applets? Nope. Okay, that's good. Java Web Start, that was removed as well. Anybody using Java Web Start? Oh, one person. Yeah, I know that I've certainly found a few people in audiences who are still using Java Web Start. And JavaFX. Anybody using JavaFX? Okay, a couple of people. That's an easy one because there is a separate open source project under the OpenJDK bigger project umbrella, and you can get builds of that from people like Gluon. Now, another thing that is very important about JDK 9 and later is compatibility. Compatibility has always been a very key feature for Java. So you could take an application that was compiled on JDK, let's say 1.2, and you could run it on JDK 8 without recompiling it. That doesn't apply to every application. Most applications, you can actually do that. Oracle have now said that clean applications that just depend on Java SE should just work on later versions. It's a little less than reassuring. I would like to see it will just work. But there are a number of reasons why you might find an application on JDK 8 doesn't move nice and easily to JDK 9 or later. So JDK 9 was significant, not just in terms of introducing the modularity system, but also from the point of view that it started cleaning up the JDK. Java is now very nearly 25 years old, and we've had lots of new features added to Java over those 25 years. But until JDK 9, nothing was really removed. Really nothing was removed. So there was a lot of technical debt involved there, and a lot of features that people just weren't using anymore, and it made sense to have a cleanup. So they started small. They said, right, we've had deprecation right from JDK 1.1. There are about 450 deprecated classes, interfaces, methods, and so on. Let's remove some of them. So they found 6 that they decided to remove, and they removed those 6. And you think to yourself, what did those 6 do that was so bad that meant they were the ones that were chosen to be removed? The answer is that when they tried to separate up all the different packages and classes into modules, they found some very odd relationships between some of these things. And to do it as cleanly as possible, these 6 were identified as something they had to remove. JDK 10 took that a little bit further. They removed a whole package, 6 classes, 9 methods, and 1 field. They also removed a number of redundant features, things like the JHAT tool, the JVM tools interface, HProf agent went away. There are a number of garbage collection options that they decided to remove as well. And this has continued with JDK 10, JDK 11, JDK 12. All of those have removed certain things from the JDK, and that could potentially be an issue as you move your application forward. Most of them, I've got to say, are very sort of small. Most of them are quite esoteric, and not many people use them. But there are a few that might catch you out. Other things are going to be removed in the future. So CMS, the concurrent mark sweep collector, has been deprecated and will be removed at some point in the future. Oracle believe that the G1 collector is a good replacement for that. It's much better, so they want to get rid of CMS at some point in the future. Nashorn, the PAC 200 compression algorithm, both of those have been deprecated and will be removed at some point in the future. Most likely they will find some other things that they want to remove as well. So the important thing here is that compatibility is not guaranteed anymore. And this is quite significant because as we're facing this faster release cycle, we need to adapt to having more potential changes to our code as we move to newer versions of Java. So Oracle have been quite clear about this, and they said new versions of Java may include breaking changes. But they have been very good, and they've said, we will give you warning. We will deprecate anything which is going to be removed, and we will give you a minimum of one release warning about something that's being deprecated, being removed. Well, that's very good of them, because if they gave us less than one release warning, that would be no warning at all. So at least we get 6 months warning as a minimum between something being deprecated and something disappearing from the JDK. Now, JDK updates is something which, because of the fact we had an update this week, is quite important. So the Oracle JDK has the idea of long-term support release. So JDK 11, JDK 17, JDK 8 are all Oracle JDK long-term support releases. However, the Oracle OpenJDK JDK does not have this concept. And this is the one that is essentially free compared to the Oracle JDK, which is from JDK 11, now under a different license. So in JDK 11, the Oracle JDK license changed. It's now the Oracle Technology Network License Agreement for Java SE. That says that you can freely use the Oracle JDK in development, in testing, in prototyping, in demonstrations. But if you want to deploy it into production and use it for your business, then you will require a commercial Java SE subscription in order to do that legally. That is a big change. So the Oracle OpenJDK JDK binaries, which are free for use, are only updated for 6 months. If you look at the Oracle OpenJDK JDK 11, that now has no more updates. So JDK 12 is the current release. JDK 11 has stopped being updated on that website. JDK 8, you can continue to use indefinitely for free. And this is something that a lot of people have kind of questioned. They said, oh, okay, if Oracle have changed the license, does that mean I can still continue using Java 8 in my deployments? And the answer is yes. They haven't retrospectively changed the license at all. If you're using JDK 8, 7, 6, or older, you can still carry on using it without any problem. The only issue that you're going to have with that is that from now on, there are no free updates from Oracle. Okay, so that was all the sort of big changes in terms of the development and the distribution and updating of Java. What did we get in terms of technical features in JDK 10? Well, we only had 6 months of development, so we weren't going to get lots and lots of features, but we did get a few things that were quite useful. Local variable type inference was the biggest change in JDK 10. This is a language level change, so it's quite significant. Now, what we're used to in Java is something like this, where we say, okay, I want to create a user list. I'm going to say this is an array list of type string, and I'm going to instantiate a new array list. I'm going to use the diamond operator so I can have type inference of the generic parameter. And then I can also say, okay, I want to get a stream from that, so I'll create a stream of string, and I'll retrieve that using the stream method. And we can use variables within loops. So I can say, okay, I want to use the for each syntax, and I'm going to iterate over the user list and retrieve the name as a string and do something with it. And we can use local variables in loops as well. So this is all very common code that we're used to. We can say int I I less than 10, I++. All good stuff. Now in Java we have var. Var means that we are more like JavaScript. Not sure that's a good idea, but there we go. So now we can do this. We can say var user list equals new array list, and important thing here, you have to then put in the generic type parameter. You can't, well, you can use the diamond operator still, but if you do, the compiler will infer the type for you as being object. So suddenly your code won't be quite the same as it was before. So if you're going to use var, and you've got a situation like that, where you use the diamond operator, you should put in an explicit type to make the code work in the same way. So in this case, the compiler will infer very logically that the type of user list is an array list of type string. In the case of stream, it will infer that it's a stream of type string because it's coming from a list, an array list of type string. We can use var in our for each loop, so we can just say var name over user list, and it'll infer string. And if we really wanted to, I don't know why you would, you could say for var I less than 10, I++ infers int. Okay, other things that went into JDK 10, there were a few what are called JEPs, JDK enhancement proposals. Now there's more than this in JDK 10, but many of them are quite low level, some of them even refer to things specifically in the JDK itself. From a developer point of view, there's not really that much that you need to worry about with those things. So I picked out a few that were more interesting. So there's now parallel full GC for G1. That was one issue where people were complaining about performance of G1 compared to the parallel collector. So now the full GC in G1 has a parallel parallel way of doing things, so that makes more sense. Application class data sharing, as I said, that was one of the commercial features that was introduced in JDK 10 to be ready for JDK 11. And that allows you to get faster startup of your application by effectively caching the internal data structures of loaded classes and then being able to load them from a file, map them into memory, and then use them straight away. There is an experimental Java-based JIT compiler called Graal, not to be confused with Graal VM. I do wish they didn't overload that term, but they have. So Graal is a JIT compiler that's designed to produce more optimized code than you get from the existing C2 JIT compiler. And even Intel contributed a JEP about heap allocation on alternative devices, so that if you've got non-volatile RAM from Intel that runs as fast as your dynamic RAM, then you can put your heap on there rather than on the DRAM. Few new APIs in JDK 10, extensions to the class libraries. Most of these are around unmodifiable collections. So you can now have within the list, set, and map interface a copy of method which will take a modifiable collection and return an unmodifiable collection. Similarly, there are new collectors for streams which will return you an unmodifiable list, map, or set. And then there's this optional or else throw, which is essentially the same as get, but I'm not quite sure why they did that. JDK 11, right? What did we get in JDK 11? This is the current long-term support release. Okay, well the first thing they extended where you could use local variable type inference, and they said, okay, we'll let you use it on lambda parameters. Okay, how does that work? Well, if we look at a very simple example here, what we've got is a lambda expression in our map, which says we're mapping from a string to the lowercase version of that string. Okay, the thing is, in lambda expressions, we already have type inference. So the compiler will know that because list is a list of strings, that S must be a string. Okay, well, we could do it this way then. So we can actually use var on S. And we say var S to lowercase of s. And you go, why would I do that? What is the possible point of doing that? And there is no point in doing it in that particular instance. You would never do that because you already have type inference. The only place where this makes any sense is if you wanted to add an annotation to the variable in your lambda expression. If you want to put an annotation on a variable in a lambda expression, you need to have an explicit type. You can't simply do it with type inference. So if you had a more complex type, using var would make the code a little bit simpler. So it's just a small extension to how local variable type inference works. JDK 11 also introduced the idea of making it simpler to run simple applications. And this is seen as a sort of something which stops people getting into Java more easily. So if you look at JDK 10, there are 3 ways to launch a Java application. You can do it simply from a class file, where you simply point your class path at something, and you say, this is the name of the class which contains my main method, and off it goes. You can do it from a jar file, so you do java-jar myjar.jar, or you can do it from modules, and you can say java-m, name the module that contains the class which has the main in it, and it will run from there. JDK 11 introduces a 4th way of doing this. So now we can actually go straight from a Java source file to a Java application. And you can say java factorial.java4. What happens then is that the Java runtime will look at the file and say, hang on, that's not a class file. It's source code. I know what I can do. I can compile that into a class file and then execute the bytecodes from that class file. What it really does is just save you the step of doing javac factorial.java and then doing Java on factorial. But we can also take that one step further, and we can say, right, let's use Shebang and create a file which has our source code in it, but we'll use the first line with a hashbang, and we'll say run our Java executable with a command line flag to say that the source code level is 11. And then, if we make that file executable, we can simply do /factorial 4, and everything will automatically happen for us, and the Java runtime will say, okay, this is source code, compile it into a class file, and off we go. This only works for one source file. You can't do it for multiple source files, but you can set the class path, and you can then have lots of jar files that work with that. But for one source file, this works quite nicely. A few other selected JEPs that we have in JDK 11. Nest-based access control is part of Project Valhalla. I'll talk about that towards the end. It's some of the groundwork that's being done to make Valhalla a reality. Dynamic class file constants, which is rather an oxymoron. It's either dynamic or it's constant. It can't be both, but it is. So we have dynamic class file constants, which are kind of like final variables for the class file constants. So you can set it once and then it's fixed. This is very useful if you're writing compilers or developing languages other than Java that get compiled into bytecodes. And there are certain situations where, in terms of performance, in terms of ease of development, this kind of thing makes sense. So that's why that's been introduced. Epsilon garbage collector came from Alexei Shibalev at Red Hat, which is a garbage collector that doesn't collect garbage. So you think, okay, what's the use of that? And there are 2 uses. One is for testing new garbage collection algorithms. So you can say, run your application without a garbage collector, run it with the new algorithm and see what the delta is, see what the performance impact of your collector is. But the other thing that people are finding that this could be quite useful is when you're doing things like AWS lambdas, serverless computing, where you've got very short-lived applications that are working as services, and you don't want the overhead of doing garbage collection because they're not going to run long enough for that. HTTP client, this was partly introduced in JDK 9 as an incubator module. Now it's part of the standard, so it's been made part of the Java SE libraries. Upgrading TLS to version 1.3, very important. And another garbage collector, the experimental ZGC, which is designed to work with very low latencies. Few new APIs in JDK 11. Most of these seem to be related to null input or output streams. So you can have an input stream that returns a null input stream from which you can read 0 bytes. You can have a null output stream to which you can send as much data as you like and nothing happens to it, which makes you think, what's the use of that? And apparently this is sort of like /dev/null kind of thing. And there are certain situations, if you're doing streams programming, where you've got a sort of functional approach to your code, where this kind of thing actually is quite useful. So they've introduced a way of doing that. Similarly with readers and writers, null reader, null writer. Optional has a new method called isEmpty, which funnily enough is the opposite of isPresent. And character has a new method called toString, which takes an int, which is a Unicode code point. String has had a number of new methods added to it. So the very obvious is blank. I won't explain what that does. It should be obvious. Lines, which will return a stream of lines. If you have line breaks within a string, you'll get a number of different strings from that. Repeat, again, does the obvious of repeating a string a number of times. And then 3, which are strip, strip leading, and strip trailing. These remove white spaces from either the beginning or the end of a string, or both. Obviously, you look at that and you think to yourself, well, what's the difference between strip and trim? Because trim does the same thing. Well, the answer is how you treat a white space. With strip, it uses the Unicode definition of white space. With trim, it is a much simpler definition of white space. My favorite feature in JDK 11 is the not method that's been added as a static method to the predicate interface. Okay, so we could do something like this, where we say filter S, and we want to filter out blank lines. Okay, it's very logical, works nicely. Now we can do it with a predicate not. So we can say predicate.not string, and we can use the method reference, string : is blank. And if we do a static import of the predicate methods, we can do this. Filter not string is blank. I just think it makes it more readable. It's just more obvious what the code is doing and not having to sort of interpret the more verbose, if you like, way of doing it with a lambda expression. Big thing with JDK 11, number of modules were removed. This is a big change in terms of the standard libraries. So the java.se.ee aggregator module, which wasn't included by default for compilation or runtime since JDK 9, has now been removed completely from JDK 11. That means that Corba has gone away, or Corba support, I should say. It means that the activation framework of part of Java Beans has gone away. JAX-B for XML binding has gone away. And the one that catches out quite a few people is JAX-WS, web services using the older SOAP-style way of doing web services rather than the RESTful way of doing them that we all use at the moment. JDK 12, right. Switch expressions. This is what's called a preview feature. And this is the first time they've done a preview feature, which means they've changed the language without changing the specification. And that's kind of a little bit odd to do that. In the past, we've always been used to switch as being a statement, which means that you do something with it, but you don't return a value from it. And the syntax of switch has always been a little bit clunky because it was inherited from the way that C did it. And C was designed for systems programming, so it had slightly different requirements to the types of applications we write in Java. Let's look at an example. So, old style way of doing things with a switch statement. We want to define the number of letters in the day of the week, and we do that with a switch statement where we say, okay, case Monday, Friday, Sunday, that's 6 letters, and we assign that value to num letters. Tuesday is 7, and so on. But it's a lot of lines of code because we have each case on a separate line. We've got to assign number of letters each time within that, and we've got to remember to put in the break at every case, otherwise we fall through. With the new style switch expression, this gets a lot cleaner. So now we have case statements with, wow, wait for it, comma separated lists. So we don't have to have a case on each separate line. We can now do case Monday, comma Friday, comma Sunday, borrow some of the syntax from the lambda expression and say that the right-hand side of the arrow is the value that is returned. We can then assign that value in a single place to the return value of the switch statement. That makes life easier because we don't have to do it in every switch statement, and that removes the potential for a lot of errors. We can still throw an illegal state exception if we need to, but again, it simplifies the way the code looks. You can mix and match. So you can actually use the old case style of doing things, and then you can break with a value, and that's actually what gets returned. So you don't have to use the arrow. You can actually do break and then 6. This is possible because you can break to a label, but a label can't be a number. So they managed to kind of get around the problem of that, doing that. And then you can even do something which I don't recommend, which is make your code look really nasty by using code blocks in your switch statements where you're using effectively the lambda expression with a code block, and you say, okay, case 1, we're going to do some complicated calculations, we're going to break out of that. Case 2, we're going to do some complicated calculations and break out of that. You can do it, I wouldn't recommend it. Other selected JEPs that we have in JDK 12, Shenandoah is yet another garbage collection algorithm that's been introduced into OpenJDK. This is the one that Red Hat have been developing for quite a long time now. There are some updates to the performance of G1. So there's abortable mixed collections, which just enables the garbage collector to break out of a situation where it's going through a set of collections and it actually doesn't need to go through all of that. So it just improves the performance that way. And also returning unused committed memory so that the JVM doesn't hang on to memory longer than it needs to, and it can give it back to the operating system so that it can continue doing its work in other applications. JVM constant API, this is to do with, again, some of the class file structures, and it's more to do with compiler developers and people who are developing languages on top of the JVM other than Java. And the last one is default CDS archive. I mentioned the class data sharing as being a way of improving the startup performance of applications. What they now do is they build a class data sharing archive for the standard Java classes, and so you don't have to build that yourself. Streams has a new method called teeing, and what this does is take 2 collectors and a by function. So essentially what it does, using the diagram here, is we take a stream, we split it, so all the values go into 2 collectors, collect those 2 results, and then pass them into a by function and take the result of that as being the result of the new collector called teeing. To demonstrate that, we could do an average. Now, I know there's an averaging method in the collectors already, but this just demonstrates it. So we say, okay, take a stream of numbers, pass that into collect using teeing. The first collector is going to be summing double, so that will add up all the values in that stream. The second one is counting, so that's going to produce a count of how many values there are in the stream. And then the by function simply says, take that sum, take how many values we have, divide one by the other, and it gives us our average value. So that demonstrates how that might work. A couple of selected JEPs, Shenandoah. I already said that, didn't I? Yes, I already had that, yes. Yes, I've said that slide. Why did I get that twice? Command line XX flags. There have been a lot of changes. This is something, again, might catch you out when you move applications to newer versions. So a lot of command line flags have been removed, 82 in JDK 9. And a lot of the removal of these flags means that when you start up an application and you try and use the same startup script, it actually won't start up. It won't ignore them. It will simply say, I don't recognize that flag. I can't start the JVM. So it's worth just having a look at that to see which flags have been removed. And there's a website here, Chris Who Codes, who does a very nice comparison. Since I'm running out of time, longer term JDK futures, there's still work going on in terms of the language. So there's a few things around lambda expressions and using a single underscore as a variable name and a parameter. Raw string literals were supposed to go into JDK 12, but they decided to postpone it because it wasn't quite ready. This is the idea of using a single backquote, and anything between that and the next backquote is treated as a string, whether it goes across lines, whether it has special characters in it, or whatever. Of course, you think to yourself, what happens if I want a backquote in my string? Well, they thought of that because you can use one or more backquotes to delineate a string. So you could have 3 backquotes, and then you could have double backquote in it. Pattern matching is again an extension to the idea of the switch statement. So now you can switch not just on an int, not just on a string or an enumeration, but you can switch on a type as well. So if you want to switch on whether it's an int, integer, byte, long, double, then you can do that using a switch statement in that way. Project Valhalla is about value types and avoiding the use of having to use primitives for performance. So that's around the idea of being able to do something like an array list of int rather than an array list of the wrapper class integer with all the overhead that you get with that. I'm running out of time, so I'm going to move on quickly. So value types is fixed values to improve the performance of the way that things work. Project Loom is a nice idea to extend the way that threads work, so that now you don't have to have an operating system thread for every thread within the Java application. You can use what's called a fiber. Essentially, this is about introducing continuations into the JVM. Okay. Since I've only got 10 seconds left, I will talk very briefly about Zulu Community. That's Azul's version of Java. Come talk to me about that afterwards if you're interested. You can download it for free from here. We provide very reasonably priced support for that if you want. And just to summarize, since I've got 25 seconds. Right, so Java continues to evolve. No, actually, I'm over time, aren't I? Java continues to evolve. So we're seeing lots of changes, both technically and from the point of view of the technical and language changes and the way it's developed and delivered. So it's something to consider about when you're moving to a new version. Is it long-term support? Where do you get that support from? Where do you get the updates from? With that, thank you very much.